Hi, for this video, we will be discussing exponential equations and inequalities. It's divided into three parts. The first will be solving exponential equations with the same base, solving exponential equations with different bases, and lastly, exponential inequalities. First, let's try to review the laws of exponents. Some properties and laws of exponents are as follows. Assuming that a here is any constant that's not equal to 0, a raised to 0 is equal to 1. A raised to a negative exponent should be 1 over a raised to that exponent or that power. Now, if you have two bases that are the same, being multiplied and then they're both raised to different exponents, what we can do is retain the base and add the exponents. If you have the same base being divided but with different exponents, you retain the base and subtract the exponents. If, for example, the resulting answer would have a negative exponent, you can apply this rule, the one on the left. So next, if you have a base that's raised to x, for example, and then raised to another power, you retain the base and multiply the exponents. And then if you have two bases that are being multiplied and both are raised to an exponent, what you can do is that you can distribute the powers. Lastly, if you have two terms that are being divided and both in a quantity are raised to an exponent, you can distribute the exponent. So let's go to the first part, solving exponential equations with the same base. Let's recall the exponential functions of the form f of x is equal to a raised to x, and then this is a one-to-one function. So if, for example, you have function of x of 1 is equal to the function of x sub 2, then x sub 1 is equal to x sub 2. So if, for example, the function is an exponential function, in this case, it's a raised to x sub 1 is equal to a raised to x sub 2, then x sub 1 is also equal to x sub 2. This means that if the two exponential expressions are equal, their bases are the same, and it should follow that their exponents must be equal. So let's try that in some examples. So how do we solve this? First, let's look at the example. Both of them have base 3. So since both of them are of the same base, what I can do is I can drop the base and deal with the exponents. So 4x minus 1 is equal to 2x plus 1, and then solve for x. This is 4x minus 2x is equal to 1 plus 1, or 2x is equal to 2. Your x is equal to 1. And since for exponential functions, the domain is any real number, I can say that my solution set is 1. So long as your operation is correct, you don't even need to check. Here, let's make them have the same bases. So that's 2 raised to x plus 5 is equal to 2 raised to the fourth power. Now that their bases are the same, x plus 5 is equal to 4, x is equal to negative 1. Therefore, for your solution, it's negative 1. And then, even if you try to substitute this, negative 1 plus 5 becomes 4. So that is 2 raised to the fourth power. Next problem. This is 2 raised to the second power raised to 3x minus 2. So you can multiply that. This is 2 raised to the third power, and then that's x plus 1. So here, let's distribute first. Since both of them have the same base now, it's 2. I can say 2, 3x minus 2 is equal to 3x plus 1. This is 6x minus 4 is equal to 3x plus 3, or 3x is equal to 7. X is 7/3. So this is your solution. That's your answer. Here, only one side has base. I can say that this one, if you want to make it just retain it as 9, x squared minus 16, I can say that this is 9 raised to 0. So both of them have base 9. X squared minus 16 is equal to 0. And then let's try factoring this out. That's x plus 4. X minus 4 is equal to 0. So your x is either 4 or negative 4. And both can be answers. So for your solution set, both are answers. 4 and negative 4. Here, it's x such that x is 7/3. For this one, 3 raised to 4 minus x, and then this is 1 over 3 cubed. This one, 4 minus x, I can say this is 3 raised to negative 3. So 4 minus x is negative 3. Negative x is equal to negative 7. X is 7. Okay? So that's your solution set. Now, you have a fraction here, but then the other one is a reciprocal. So what you can do is 4/5 2x minus 7 is equal to, I can make this 4/5, but then I can make that negative 3x. So, since both have the same bases, 2x minus 7 is equal to negative 3x, transposing 3x, that becomes 5x, and then this becomes 7. Therefore, x is 7/5.